Question 1. Change 40 centimetres into millimetres. We should know that 1 centimetre is equal to 10 millimetres. We could also look at a ruler. Therefore, when converting centimetres into millimetres, we multiply by 10. Hence, converting 40 centimetres into millimetres, I'm going to do 40 multiplied by 10, and 40 times 10 will give us 400 millimetres. Question 2. Here we're asked to simplify e plus e plus e plus e. We can only add or subtract like terms, and like terms have the same combination letters. As they all end in e, they are like terms. Hence, we just add or subtract the numbers in front. If there's no number in front of a letter, we know the number is 1. Hence, just adding up my lots of e, 1, 2, 3, 4, will simplify to give us 4e. Question 3. On the grid, we're asked to reflect the shaded triangle in the mirror line. When we're reflecting in the mirror line, we end up with a mirror image. Any vertices on the mirror line will stay exactly the same position. This vertex on the right was 1, 2, 3 squares along the right. Therefore, it's now going to be reflected, therefore 3 squares on the side on the left. Joining up my vertices. Question 4. We're asked to write down the value of the 6 in number 16,007. Reading all from the right, our first column is our ones, our second column is our tens, our third column is our hundreds, our fourth column is our thousands. As our 6 is in the thousands column, therefore the value is 6,000. Question 5. Write these numbers in order of size. Start with the smallest number. As I've got a fraction decimal percentage, I'm going to start by converting each of the following to a decimal. Well, a half as a decimal is 0.5. 0.55 is already a decimal. When we're converting a percentage into a decimal, we know percent has the 2 zeros, which means it's out of 100. So when converting a percentage to a decimal, we always divide by 100. So 45 divided by 100 as a decimal is 0.45. Looking at my 3 decimals now, the smallest one reading from the left would be my 0.45, which is my 45%. My next smallest would be my 0.5, which is my half. And my next smallest would be my 0.55. Question 6. The pictogram gives information about the number of hours of sunshine on a Saturday and on a Sunday. Whenever dealing with a pictogram, my first step is to always look at the key. Here we know 1 full sun represents 2 hours of sunshine, and we were asked to work out the number of hours of sunshine on Saturday. Looking at our row for Saturday, we know each full sun represents 2, so I've got 2, 2, 2 and 2. Adding them together, well, 2 add 2 is 4, 4 add 2 is 6, and 6 add 2 is 8. So I've got 8 hours of sunshine on Saturday. Question 7. Simon buys some candles. Each candle costs £2. Simon pays with a £20 note. He gets £6 change. Work out the number of candles Simon buys. As he paid with a £20 note and he gets £6 change, I'm going to first of all work out how much he spent. Well, 20 take away 6. I can't take 6 from 0, so I borrow from its neighbour. 2 drops to 1 and I carry the 1. 10 take away 6 gives us 4, and 1 take away 0 gives us 1. So he spent £14, as each candle costs £2, and I want to work out the number of candles he bought. I'm going to do 14 divided by the price of 1 candle. Well, 14 divided by 2 gives us 7. So he bought 7 candles. Question 8. The bar chart shows information about the total rainfall each month for 4 months in a city. In May, the total rainfall was 35 centimetres. In June, the total rainfall was 20 centimetres. And we're told to use this information to complete the bar chart. When drawing a bar chart, the width of each bar must be the same. In this case, we can see each width of the bar is 1 square. Therefore, the width of May and June must also be 1 square. The height of the May bar must represent the total rainfall, which is 35 centimetres. So for May, we're going to look at the scale, go up to 35, and it's going to have a width of 1. And I'm just going to use a ruler and make my bar. Repeating this process for June, we now have a total rainfall for June for 20 centimetres. So my height of my bar for June, look at my scale, must go up to 20. And again, the width of my bar must again only be 1 square. Rupert said, in February, there was 15.5 centimetres of rainfall because the bar is half a square above 15. Explain why Rupert is incorrect. Well, looking at the height of the bar for February, I can see it is half a square above 15. But looking at the scale, I should see that 1 square represents 5 centimetres of rainfall. Therefore, half a square would represent 2.5 centimetres of rainfall. Halfway between 15 and 20, therefore be 17.5. So there's actually 17.5 centimetres of rainfall in February. Question 9. Here is a sequence of patterns made from grey squares. On the grid below, draw pattern number 5. Looking at the pattern, here I can see it's 1 along and 1 down. Here it's 2 along, 2 down, 3 along, 3 down. Next one's 4 along, 4 down. So pattern 5 will be 5 along and 5 down. For part B, we're asked to complete the table. Looking at number of squares, we have 1, 3, 5, 7, which shows that each time we're adding on 2. Therefore, 7 add 2 will give us 9, and 9 add 2 will give us 11. Question 10. In Norway last year, the lowest temperature was negative 15 degrees Celsius. In Norway last year, the highest temperature was 42 degrees Celsius, greater than the lowest temperature. Work out the highest temperature in Norway last year. Well, we know the lowest temperature was negative 15 degrees Celsius, and the highest temperature was 42 degrees greater than lowest, so I'm going to add on my 42. Well, negative 15 plus 42 gives us 27 degrees Celsius. Negative 15 plus 42 is the same as having 42 subtract 15, because the sign always belongs to the term it precedes. We can't take 5 from 2, so we borrow from its neighbour. 4 drops to 3, and we carry the 1. 12 take away 5 gives us 7, and 3 take away 1 gives us 2. Hence is 27 degrees Celsius. Question 11. At the end of October, Fiona's electricity meter reads 88,738 kilowatts. At the end of November, her electricity meter reads 89,198 kilowatts. Each kilowatt of electricity Fiona uses costs 16 pence. Work out how much Fiona had to pay for electricity she used in November. Our first step is I'm going to subtract our two readings. It's always going to be the largest number, subtract the smallest number, i.e. the end of November, subtract the end of October reading. So in this case, we're going to have 89,198, subtract my 88,738. That's to work out the number of kilowatts she used in the month of November. 8 subtract 8 gives us 0. 9 subtract 3 gives us 6. We can't take 7 from 1, so we borrow from its neighbour. 9 drops to 8 and we carry the 1. 11 subtract 7 gives us 4. 8 subtract 8 gives us 0. And 8 subtract 8 will give us 0. So Fiona has used 460 kilowatts of electricity for the month of November. As we know, each kilowatt of electricity costs Fiona 16 pence. And Fiona uses 460 kilowatts for the month of November. To work out our price, I'm going to do the number of units used, 460, multiplied by the unit price, in this case 16. Well, 6 times 0 gives us 0. 6 times 6 gives us 36. So I'm going to put 6 down, carry the 3. 6 times 4 is 24. Add the 3 gives us 27. Now dealing with my tens column, I put a 0 down in my place value. Well, 1 times 0 gives us 0. 1 times 6 gives us 6. And 1 times 4 gives us 4. 0 adds 0 gives us 0. 6 adds 0 gives us 6. 7 adds 6 gives us 13. So 3 down, carry the 1. 2 add 4 is 6. Add the 1 I carried, gives us 7. Hence my final answer is 7,360. And that's in pence. Or in terms of pounds. Question 12. We're asked to work out 5 12s plus 1 6th. In order to add fractions, we must have a common denominator. The lowest common multiple of 12 and 6, i.e. the first number that appears in the 12 and 6 times table, is in fact the number 12. Therefore, I'm going to change each denominator to have a denominator of 12. The first fraction already had a denominator of 12, so hence I leave the numerator exactly the same, the top number. The second fraction is 6 and has now become 12. What have I times 6 to get to 12? Well, I've times it by 2. Hence, I must do the same to the top to keep it equivalent. Hence, 1 times 2 gives us 2. Now that I've got the same denominator of 12, I leave the 12 alone and just simply add the numerators. So 5 add 2 gives us 7. For part B, I'm asked to work out 3 tenths multiplied by 5 eighths and to give your answer as a fraction in its simplest form. When multiplying fractions, I just multiply the tops and multiply the bottom separately. On the top, 3 times 5 gives us 15, and the bottom 10 times 8 gives us 80. As it says to give my answer as a fraction in its simplest form, as they both end in 5 and 0, therefore I can know both top and bottom are divisible by 5. 15 divided by 5 on the top gives us 3, and 80 divided by 5 gives us 16. There are 15 sweets in the jar. 4 of the sweets are red. Jill takes at random a sweet from the jar. Write down the probability that the sweet is red. The way that probability works, it's always the number of successes on the top out of the total number of possibilities. As we want to write down the probability that the sweet is red, well, there are 4 red sweets in the jar. Its number of successes is going to be 4 out of, i.e. divided by, the total number of sweets in the jar, which in this case is 15. There are only green counters and blue counters in the bag. A counter is taken at random from the bag. The probability the counter is green is 0.3. Find the probability that counter is blue. Well, the probability of a single event always adds up to 1. As I know the probability of green is 0.3, and there's only green and blue counters in the bag, therefore the probability of getting a blue counter must be 1, subtract the probability of getting a green counter. In this case, 1 subtract 0.3, which gives us 0.7.